these are the postulates and theorems we had last time. Corresponding angle postulate, alternate interior angles theorem, alternate exterior angles theorem, and consecutive interior angles theorem. Sometimes this is called the same side interior. There's also same side exterior angles. So all these kinds of angles are going to be congruent if the lines are parallel. So let's see. Just a little review of what a converse of a statement is. So if I have a statement, P implies Q. What's the converse of P implies Q? Yes, sir. P implies Q, Q implies Q. Right? So we're going to be dealing with some converse. So the converse of the postulates and theorems about parallel lines and transversal are also true. Here's another little review. So if you have a statement and its converse is true, what do we know about the statement? Well, they will be too. But what do we call a statement whose a statement and its converse are true? What do we call that? A biconditional. So those things we learned about parallel lines are biconditional. So if you have an alternate interior angle, if your lines are parallel, the alternate interior angles are congruent. If the alternate interior angles are congruent, then the lines are parallel. So we're going to be looking at those theorems. So here they are now, the converses. So we had a corresponding angle postulate. This is the corresponding angle converse postulate. If two lines are cut by a transversal such that the angles are congruent, then the lines are parallel. So if you think about what we had before, we started with our hypothesis being this. If the lines are parallel, the conclusion would be then the angles are congruent. So we are including this. We are taking a converse. So our old conclusion is now our hypothesis, and our old hypothesis is now our conclusion. The alternate interior angles converse theorem. So if you have transversal cutting two lines such that the interior angles, alternate interior angles are congruent, then you can conclude lines are parallel. Same with alternate exterior angles. Two lines are cut by a transversal such that the alternate interior angles are congruent. That's enough to prove the lines are parallel. And same with consecutive interior. If your consecutive interior angles are supplementary, so we have to be careful with that, then the lines are parallel. So just like anything else, postulate, we're going to assume that's true. You have to prove the other's true. I can't use a theorem. I can't use a conjecture until we prove it true and it becomes a theorem. So we're going to start with the alternate interior angles converse theorem. I'm a little trouble talking today. So here's our conjecture. If two lines are cut by a transversal, so here's two lines, they're cut by a transversal, such that the alternate interior angles are congruent. So I can assume these two angles are congruent. That's my given. Angle 4 congruent to angle 5. I want to conclude now that they're parallel. I don't know they're parallel unless I can prove this. So here's my given. Now I'm saying 1 congruent to 4. Well, why are 1 and 4 congruent? Vertical angles are congruent, right? So we got that. Then we're saying angle 1 is now congruent to angle 5. How do we conclude that? What's going on here? From here to here to get to here. Yeah, we got some transitivity. This is congruent to that. That same thing is congruent to this. So these two things are going to be congruent. That's that transitivity of congruence now. And because angle 1 is congruent to angle 5, that's what we wanted to prove now. Oh yeah. Now these two are congruent. We have a postulate where we're assuming things are true. That if the corresponding angles are congruent, then we have parallel lines. That's a corresponding angle converse postulate. So now we have that. So good, we've got two of them now. Let's look at consecutive interior angles. This one assumes that you've got two supplementary angles. The consecutive interiors are supplementary. We're going to go with that given. And we conclude evident or parallel. Well, here's my given. So why are 5 and 6 also supplementary? Why are these supplementary? 5 and 6? Yeah, how come? They're a linear pair, therefore they are supplementary. That was the linear pair postulate, wasn't it? So if you have supplementary angles in a linear pair, you've got the linear pair postulate. Let's see, angle 3 and angle 6 are congruent. Yeah. Well, I just got supplementary. All I know is 3 and 5 supplementary, 5 and 6. Supplementary, supplementary. So how come I can conclude these are congruent? It says it right here. We have the congruent supplements theorem. If two angles are supplementary to the same thing, then they are congruent. That was, we have congruent supplements and congruent complements. So it's a little handy thing right there. Therefore, M is parallel to N. Well, let's see. These are alternate interior angles. We just proved that if you have alternate interior angles that are congruent, the lines must be parallel. So that was the theorem we had just proven. So we're good. We've got this one now. Alternate exterior angles. Let's see what we can do for those. So alternate exterior angles are on the outside, and they alternate around the transversal. If they are congruent, right, that's our given, can we conclude that M is parallel to N? Well, let's see, 2, 7, that's our given. Angle 2 and 4, we're saying that they're supplementary. Why are these supplementary? Because they're a linear pair, and linear pairs are supplementary by the linear pair postulate. Angle 7 congruent to angle 6. Why are angle 7 and angle 6 congruent? Vertical angles, okay. 6 and 4 are supplementary, so what happened here? So 2 and 4 are supplementary, 7 congruent to 6, 7 congruent to 2. So we're kind of skipping a little something here. When I see these two things, what can I conclude? And 2 is congruent to 6 by transitivity. It's like we're missing a little step here. And then 2 and 6 are the same thing, so I can replace 2 with 6. That's substitution. So 6 and 4 are supplementary. Well, let's see, if 6 and 4 are supplementary, that's these two, then it must be I have parallel lines. That was the last theorem we just proved, consecutive interior angle Converse theorem. Converse. So there we go, yeah, we're perfect. So that's nice. So now we can use this fact that if you have congruent angles, those angles we've been studying, you can conclude parallel lines. So here's an example of something you can do. Find the value of x that makes n parallel to n. Well, what has to be true of these two things to make those parallel lines? Yeah, we have to do it. They have to be congruent. So that means that 3x plus 5 has to equal 65. So 3x is going to be 60. X will be 20. Right? So that's what we have to do to make those lines parallel. Can we prove M is parallel to N? Can we? And can you explain how? What do you think? Somebody want to give it a shot? I'll say you know this so well. Yes, sir.
The one angle above 1 and 5 is 75.
This guy right here?
No.
This one. Okay, why is he 75? Well, but I don't know they're parallel. Right? It says, can we prove them? So I can't assume they're parallel. I'm trying to prove it, but you are so on the right track. You're so on the right track. Can you build on what he's got here?
75
Right. Linear pair postulate, right? I've got a linear pair. They're always going to be supplementary by the linear pair postulate. So this is going to be 75 because 180 minus 105 is 75. Now what am I seeing? You're on the right track, right? See these two now? What kind of angles are those? Yeah. Corresponding angles, right, top right. And if the corresponding angles are congruent, then we have parallel lines. That was the corresponding angle postulate. Makes sense? So why is this? We should give us numbers. We're going to call this angle 1. Angle 1, the measure of angle 1 is 75 degrees by the linear pair postulate. You can see that the measure of angle 1, I'll call this one 2, equals the measure of angle 2. What's the reason? Just the north? So what does that mean? Angle 1 congruent to angle 2. Definition of congruent. So therefore, M is parallel to N what the book calls these things. That was the corresponding angle converse postulate. So I have trouble remembering all those big words to me. But I can remember that the corresponding angles are congruent with lines parallel. That to me is easier to remember. Okay, so let's see. Can we prove A parallel to B here? So we've got an angle 1, we've got an angle 2. We're told if you add those two together, you get 180. So can we prove they're parallel? Take a look. What do you think? I'll call on somebody, that's okay. Let's see. It looks like they might have some idea what they're doing. Rachel, what do you think? I know that these two things add up to 180, so if two angles add up to 180, they are, what's that word? Two angles that add up to 180. Right, they're supplementary angles. What kind of angles are they? They're alternate interior angles. So if alternate interior angles are supplementary, can we conclude that they're parallel? Can we? Well, I know they have to be congruent, right? But is supplementary good enough? What do you think? Okay, so since they're supplementary, so you're saying if I put a 3 here, here? Yeah. Okay. These would have to be congruent? No. Why would they have to be congruent? They're same side interior. What do we know about same side interior? They're supplementary. So that's still following. These are supplementary, these are supplementary. What do you think? What's going on? So we can? No. So why not? We don't have enough information. We know alternate interior angles. If they're congruent, we have parallel lines. Do we have anything that says if they're supplementary? And as a matter of fact, what's the only case where if they're supplementary, we're going to get parallel lines? When they're 90 degrees. It's the only time it's going to work. Did they tell us it's 90 degrees? So we don't have enough information. We don't have a theorem or postulate because it's just not true. Which is just not true. So that one, no, we don't have enough information. We don't have enough information. Alternate interior angles, supplementary, not proven to show parallel lines. And I think we can just see it just doesn't make sense. Okay, then you can put numbers in. What if this was 100? And this one was 80, right? You're not going to have parallel lines in that situation. Okay, new theorem. Yay. This one is called the transitive theorem of parallel lines. Transitives. Remember what transitive? With equals, A equals B, B equals C, A equals C. So now with parallel lines, what do we have? If P is parallel to Q, and Q is parallel to R, what can we conclude? P parallel to R. Same thing. Same transitivity. So let's see. Oh, good for this. I guess we do. All right, so we're given parallel lines. P to Q and Q to R. Angle 1 is congruent to angle 2. Why is that? Why are angle 1 and angle 2 congruent? Yeah? Which states alternate interior angles of parallel lines are congruent. All right, so I go with that. Angle 2 is congruent to angle 3. Why? Vertical angles are congruent. Angle 3 congruent to angle 4. Why? Alternate interior angles. So now I'm saying angle 1 to 4. Well, what happened here? We're going from here to here. So 1 is congruent to 3, right? And then 1 has to be congruent to 4 using transitivity. So 1 is congruent to 4. What's going on there? Those are alternate interior angles of the outer line. So if I've got alternate interior angles that are congruent, so they're therefore I've got parallelism. So if you know two things are parallel, you know, and there's the same line in between, they're going to be parallel to each other. So here's an example. In the figure, right, each rung of the ladder is parallel to the rung directly beneath it. So if this one is parallel to the one beneath it, this one is parallel to that one. Explain why the top rung is parallel to the bottom one. Right? So I think I put some words here. I used a paragraph proof. So let's see. Rung 1 is parallel to what? And that's a given, right? It says that they're parallel to the ones underneath. Looks like I've got neat handwriting over here. Okay? And rung 2 is parallel to rung 3. That's our given. Therefore, rung 1 is parallel to rung 3 by the transitive theorem of parallel lines. Now, can I repeat this? I'm going to repeat this all the way through, and then you can conclude the top is parallel to the bottom. Fantastic. Okay. This one's complete review. Complete review. I know you guys know this too. Blast from the past. Slope of a line. Does this look like a foreign language to anybody? It should. There's some Greek in there. M equals delta y over delta x. Remember that? Difference in y over the difference in x. That's how we get the slope of a line. It's a ratio. Changing y, changing x. So let's see. Remember how they work. Parallel lines have the same slope. And I think that one's kind of easy to see. If slope is a tilt of a line, so wouldn't parallel lines have the same exact tilt? So therefore their slopes are parallel. And perpendicular lines, they need at right angles, their slopes are negative reciprocals. Who remembered that one? So again, let's review. So if I have a slope, well, if I have a slope of 1/3, what's the slope of the line perpendicular? What's the negative reciprocal? Emily? -3. What if your slope was -2/5? What about the perpendicular line? Isha? You have to do two things. Change the sign and, you know, invert your numerator denominator. It's not so bad. So what do we got here? Just reviewing slope a little bit. Positive slope. As x increases for positive slope, as your x increases, what happens to your y? It increases. So which line is that? Line K. So here's an example of a positive slope. Right? So as your x increases, your y increases, that's where you're going up. Positive slope. Negative slope. So as x increases, what's happening to your y, your negative slope? Decreases. Which one is that? Line J over there. Excellent. I'm on the back here. Hopefully you were following along. Zero slope versus undefined slope. Which one is a zero slope? Michelle? L. How come? This one is the one that you could walk on, right? The one that it's not tilted at all, is it? Its slope is 0. So a horizontal line is going to be this line L. Slope is 0. What about the undefined slope, sir? Line N, because why? It's vertical. Undefined slope. Why is that undefined? Like, how do we keep this straight? Yeah. Yeah, my change in my x doesn't change, does it? My x stays the same. So I'd be dividing by 0. Can we divide by 0? No. You can't divide by 0, so that's one reason it's undefined, right, Nathan? Yep. I know sometimes they just want to memorize stuff. I'd rather you just think about it. You know, why is the horizontal one 0 and why is the undefined one vertical? Okay. New postulates, old knowledge. So now we're just going to give some postulates so that we can use them in proofs if we need to. Slopes of a parallel line. Postulate. In a coordinate plane, two non-vertical lines are parallel if and only if they have the same slope. If and only if, so what does that mean? Because I'm saying that if and only if. What does that mean? It's a biconditional, so it must also be true that if you see two lines with the same slope, then they're parallel. And any two vertical lines are parallel. Now, why do I have to do vertical lines separate? Yeah, how come? Exactly. Because I'm using slope in my definition, the parallel line for the verticals, that won't work because they don't have a slope. So we just kind of put them out separate. We also have perpendicular lines. In a coordinate plane, two non-vertical lines are perpendicular if and only if the product of their slopes is -1. Well, that's different than what we said before. Didn't we say if they have negative reciprocal slopes? So what's going on here? This is slightly different. Why? What's going on? Oh, really? We don't know. We know. We don't want to say, Thomas, how come? Well, there we go. Let's say I have a slope, and it's A over B, right? Nice generic slope, B's not 0. Okay, so what would be the slope of the perpendicular line? Negative B over A. Now, if I were to multiply these, well, what am I going to get? Next time. Okay. Because I can, those cancel out, what am I left with? -1. So the product of a number and its negative reciprocal is always -1. So it's another way of saying the exact same thing. So if they multiply, the slopes multiply to -1, they have to be negative reciprocals. Yes? What do you mean there's nothing? I divide both sides by A, I'm left with the 1, right? I divide both of these by B, I'm left with the 1. 1 times -1, 1 times 1. Right? So when I'm cross-reducing, I'm dividing, you're going to be left with 1, not 0. Horizontal lines are perpendicular to vertical lines. Now, how come I have to call that out separately? Well, how come? It's going to take a long time. You're not putting on any participation. Yes? Right. So I can't multiply the slopes of this. I can't multiply 0 by an undefined number. So I have to call it out special. So perpendicular lines have slopes that are negative reciprocals of each other, and it's the same as the products being -1. So you can look at it either way. Either way. Okay, so which of any of these lines are parallel? Which of any of them? So let's see. How do I figure this out? Please. Yes, sir.
You put the slope for all lines.
Okay. How do I find the slope? Connor, go ahead. How do I find the slope?
5, 9,
Which one are you doing? We got blue, we got red, we got green.
3.
This one. Start over here.
3 minus -3 equals 5.
So you're doing y2 minus y1. Yeah, over.
And then 6 minus 5 is 1. 5 and 1.
So this one's 5? Okay. All right, what about the other ones? Which ones would you like to do, Jake?
Red.
He's going to do red, okay?
So we do 5 minus 1, and then I'm going to do 4 minus 2,
Okay.
and we get 4.
Which is 4. Okay. Blue line left. Miss Neil? That's 4 over -2 plus 3, right? And that's also 4. Any of the lines parallel? Yes, sir. Yeah, I was wondering if anyone was going to say, you know what, I didn't do that. I kind of took the easy way out. Remember the other way to do this? What's my change in y? 1, 2, 3, 4. I'm going 4 down, and then I went 1 left. That's also 4. I put it down to this one. 1, 2, 3, 4, 1. Same thing. 1, 2, 3, 4, 5, 1. Absolutely. They give me the graph, why not? But do I have any parallel lines? Yes. Line K1 and line K2 because same slope. That's it. Well, that's easy. Let's see. Can we graph the line parallel to this line that passes through point P? Let's see, yes, we can. So how do we do that? I've got a little clue here. Slope of, yes, ma'am. Okay, what's the slope? And I kind of like the Dominic method for this. She's working it out, so you're figuring out the coordinates. What's another way? Let's say I can go up one and right one. So what's my slope? 1. So what's the slope of the parallel line going to be? 1. So here's point P. Once you have a point and you know the slope, you should do that same thing. 1 over 1. Remember up and over? I go up one, right one, up one, right one. Or down one, left one. One way to approach it. What do you think? Okay. Well, let's try it for perpendicular now. So let's see, I've got a different line here. What's its slope? Yeah? What's the slope? It's also 1. Up one, right one, right? So that's also got a slope of 1. What's the slope of the perpendicular line going to be, Andrew? Negative 1. Now, negative reciprocal, 1 over 1, you see, there's nothing to do there. We just take the negative. So now if I want to graph that, remember how that works? Down 1, right 1. So go down 1, right 1. Down 1, right 1. Down 1, right 1. Or up 1. This is perpendicular. I can put my little box there. Because I know the slopes are negative reciprocals, or if I multiply them together, I get negative 1. I've got perpendicular lines. We know it. Questions? It's an easy peasy, I think. It's a review, complete review. So I want you to work on these U tries, and then we'll see how we do. Let's see how we do. So what I got, what you guys get? Same thing. Anybody want to do one? Not really sure. Yes, ma'am. A? All right, let's figure out the slope. So the slope for line 1, I've got, let's see, 5 minus 2 over negative 3 minus negative 5. We're getting 3 over negative 3 plus 5. Hopefully I did that right. 3 halves? Is that what you got? Okay, so now let's try line 2. So this is for line 1. And let's try line 2. 0 minus 2 over 1 minus negative 2. Negative 2 over 1 plus 2 is negative 2 over 3. So I've got 3 halves, I've got negative 2/3. If we don't see that they're negative reciprocals, you can always try multiplying them. And let's see what I get. Well, these are going to cancel, these are going to cancel. And I do get a negative 1 of your product, so I know they're perpendicular that way. Yeah, I wrote a mistake somewhere. Probably in the slope somewhere, I didn't write it in the mistake. So not bad, right? Easy peasy.